Today we're going to be discussing LD50 and dose response. This is a tutorial video to go over a couple of the problems on this worksheet. You should have this worksheet in front of you if you're watching this video. If not, you'll be able to practice the problems as well. So this is a first introduction, and what I want you to do is to read and annotate this, but I'm going to go over some of the key points. So chemicals can harm humans in a number of different ways. Any type of chemical could be toxic, but it depends on the dose or the amount. And so what we're going to be looking at today is how toxic is toxic really. So toxicologists are scientists that study how chemicals cause damage to living tissues or living things. So what they do is they study the toxicity of certain chemicals. So depending on how toxic something is, it's going to have a larger effect on certain organisms. So the way they do this is they set up experiments where they expose animals, usually mice or rats, to certain amounts. And they increase that amount and they see what happens. The LD50 is the value that kills 50% of the population, and that's the amount that is what scientists determine to be harmful. The LD50 for aniline, for example, is 250 milligrams per kilogram. So what that means is that 250 milligrams per kilogram of the rat's body weight is going to kill 50% of the population. So the higher the LD50, the less toxic it is. There's no data for humans because there's no ethical way to study the toxicity of humans, but what we have scientists do and regulatory agencies come up with is that safe exposure for humans is usually 1,000 times less than the LD50 for rats. There are also some ethical questions to go with rat and mice studies, but this is what is commonly used in science today. In general, chemicals with LD50 values less than 300 are highly toxic. Those between 300 and 1,000 are moderately toxic, and those between 1,000 and 5,000 milligrams are only slightly toxic. And because it depends on body weight, what is very toxic to an adult may be less, very toxic to a child may be less toxic to an adult. So the first thing we're going to look at is a dose response curve. This is a very important curve that you're going to see. And so what you're going to do on this curve is you are going to go to 50% because that's the amount that is killed. And then you're going to go down, and this number here gives you the LD50. So in this example, we have 10 milligrams per kilogram. So that would be an incredibly toxic chemical. And if we were to find the value that was safe for humans, you just move your decimal place 3 times and you get 0.010 milligrams per kilogram. This is a very toxic chemical. The next couple of problems are examples that you will get from the reading. So I'm not going to go over those, but I am going to scroll down to number 5, which is a dimensional analysis problem, meaning that you're going to have to do some conversions to get to the answer. So if the LD50 for caffeine is found to be 300 milligrams per kilogram, how many cups of coffee would you have to drink to reach the lethal dose? Each cup of coffee has 90 milligrams of caffeine, and 2.2 pounds is 1 kilogram. So we are going to complete dimensional analysis. So what that means is I'm going to think about what is the unit I'm looking for. I have to cancel everything else out, and so I am looking for cups of coffee. So I'm going to write C for that, and that's what I want to end up with. So remember, in dimensional analysis, it's all about crossing out your units. I use these nice boxes to do that, but you don't have to if you like to do it another way. But it is very important that you show your units. So the first thing I do is write down, what do I know? I know that 300 milligrams of caffeine is 1 kilogram. So then the next thing I'm going to think about is how can I cross some of those units out? How can I cross out kilograms? So I also know that 1 kilogram equals 2.2 pounds. So we've already crossed out kilograms. That's great. And then how can I cross out my caffeine? Well, I know that 1 cup of coffee equals 90 milligrams of caffeine. So that can then cross out our milligrams of caffeine there. And then the last unit that we still have is pounds. So the last thing that you can do is you can multiply by your weight. So everyone's answer is going to be different. To make the math easier, I'm just going to put 100 pounds. So this is going to tell me the amount of cups of coffee for me individually or someone else. So you can cross out pounds. And then in order to solve this, you're just going to multiply 300 times 100, divide by 2.2, and then divide by 90. And what you end up getting is 151 cups of coffee. That is a lot of cups of coffee, which is good. So that's why, even though it is technically a chemical that can be considered toxic, this is how scientists calculate it. The next example is going to be looking at an actual set of lab data. So what you're going to do is you are going to look at a set of data. So what we did in a lab previously was we studied what the effect that salt had on plant salinization levels. So what we did was we looked at this data table and we filled this out. So what we did was there were 9 groups in our class, and what you did was you exposed the different seeds to different levels of salt. So ranging from 0% salt water to 2.5%. And what you looked at was how many seeds germinated, but what we're going to look at is how many of the seeds died. So I just plotted our data. So if you do not have this data, you can pause the video and copy down this chart. Then you are going to graph the chart. Make sure that all of your axes are labeled. And then you're going to label the chart. The next part of this worksheet is you're going to come up with your own experiment. So it is very important that you know how to identify independent variables, dependent variables, and then some controls. So you're going to pretend to be a toxicologist. And then the last few problems are some more examples that have to do with the dimensional analysis and really just some higher level thinking questions that you're going to have to complete. So I'm going to let you complete those, but hopefully this tutorial has been helpful for you on LD50 and dose response.